All right, I think we're going. I believe. So let's get this party started, shall we? I want to figure out where we're at. Yep, I don't need you. I need you. We're live. Great. Okay. So today I hope you can hear me okay. There may or may not be workmen downstairs in my house, fixing my floor, putting in a brand new floor because our house flooded a couple weeks ago. So every now and then you'll probably hear a table saw or something. Apologies all the way around, but that's the way it is. There we go. And now I have my audio turned off. And I think we're good. Awesome. Okay, so let's jump in. Let me show you what we've done. This is episode 4. Episode 4, building a game. The last app that I built took over 2 years to build. It was a lot. It's in the store now, which is great. But I want to do something just for fun. And I want to do something really quick. So this is something we're going to build in 2 weeks. And after 2 weeks, it is hopefully of sufficient quality that we can send it to the App Store. And just put it out there for free and let people play around with it. And I think it'd be great. The best part is all the code is going to be open source is the goal. And all of the development of the app is also going to be live streamed. So 100% is going to show up on the stream, and 100% of the code is available for download. Let me get that up on the screen. Physics, yeah, this guy. So that's the GitHub repo right there on screen. It should also be in the description, so you can just pull it down. Let me walk through what we have so far. You can pick stuff up by the points, and you can toss it around, which is pretty great. Pause the animation. You can create sticks, and sticks are always the same length, no matter what. And so if we make that point right here on the top right immovable, it won't move with physics, but the rest of it will with gravity, which is pretty great. The other thing that we made 1 or 2 streams ago was the piston. And the piston is a stick that changes length. It just goes back and forth by about 40%. So if I attach, let me turn it off so I can get it. There we go. And now those are all working, which is pretty great. So that's a piston. The other item we made, which I actually want to work a little bit on today, is the engine. An engine has the 2 endpoints, just like a stick. And it also has a point here in the middle that just goes back and forth. Right? Pretty great. So we did pretty good on that yesterday. That's what we did yesterday as we made that engine. I want to try building that a little bit different way today. And then we will work on, maybe we'll work on wheels, maybe we'll work on animation for when a stick breaks. I can show you that. So a stick can break. Let me turn this off. So if we have, let me drop that. So if we have a guy there and a guy here, and then, I don't know, maybe like that. Is that going to break the piston? No, it's not. But if I do this, it will. Ooh, no, it still won't. That's interesting. So you can see how those 2 lines on the left are getting red. That red is the amount of stress on those sticks. Let me clear this. And if a stick or a piston or an engine or anything else gets too much stress, then it breaks. Obviously. There we go. Let's see if that'll do it. No. Anyway, you'll have to trust me on it. It just disappears. Bink. And then here. And then here. Anyway, you'll have to trust me. The stick will break. So those are the features that we have so far. What I would like to do today is refactor the engine a little bit so it makes more sense. What I would like to happen on the engine, and I think would be fun, is right now this that guy in the middle, that dot in the middle, it can actually get pulled apart a little bit. So let me do that and that and that and that. So you can see, now you can see that dot getting pulled off of the engine line. And that's because the stick that's connecting those two engines is forcing itself to stay the same length, which is pulling the dot off of the engine. I hope that makes sense. So what I want to do is, if that dot gets pulled off of the engine too far, then I would like it to snap off of the engine, which I think would be great. And yeah, if it snaps off of the engine, I think that would be cool. And then the engine kind of reverts to what we call a stick, and then whatever was connected to the engine just kind of falls off and flops around. So that way machines break in an interesting way. So let's try and do that today, where the engine can break nicely. Maybe we'll do, I'd like to do wheels, possibly. Maybe we'll do that today. Maybe we'll do animations today. We can do a couple of different things today. But let's look at, okay, cool. Let's look at the engine and see if we can get a better way. Let's do, let me walk through what it does, how it updates things. So we have each frame. This is basically our tick. We're just doing a draw rect and doing everything in Core Graphics. We clear the screen. We update all of our machines. So this is going to update the points with gravity and velocity. Tick machines. This is going to update pistons, and this should also update our engine. And then this guy enforces our gesture. This is our move point gesture. This is, and this are to make sure that sticks and pistons and whatever else are always the same length when they try to be the same length. This removes sticks that are broken or should be broken, and then we render everything, right? So our animation is probably going to jump in right here when we kill sticks. We'll add animation stuff here. And what I would like to do is update this guy to better handle our engine, so our engine works a bit more like a piston. So a piston, when it ticks, it creates, it just updates its angle, which is going to then, when it is constrained, a piston extends a stick. So when that guy is constrained, it looks at its length here and figures out what its actual length is compared to what its current length is, what it wants its length to be compared to what its length actually is. And then it updates its stress values and everything else based on that, which is fine. And so this is how I want to handle the engine the same way. And right now we don't. We handle our angle here, which is fine. But we just force that third point on the engine. We just force it onto the actual engine path. So if I show you every update, instead of this point right here on the engine being bound to this line by physics, by air quotes physics, we just force it, which is not very fun at all. And so I want to force it, and I think that would be interesting. So let's get a few different things in here. And I want to create two different things. Let's also, we'll make a branch and to play around with the engine in case I royally screw something up. I want to make two different engine parts. Engine, we'll call it an engine piston, which is a terrible name. And let's put it there. I know nothing about real life engines, by the way, so these names might not make any sense. Engine shaft, isn't that a thing inside of an engine? And then stick, yeah, they're both going to extend stick, which is great. This guy did not and should have. Oops, yeah. Okay, great. So here's my thought of how I want it to work. I want to build this point, this third point, out of things that we already have inside of our engine. And so instead, I want to do this line will be our new engine. It's just going to be a regular old stick, and it's going to have two parts. Oops, the first part. There's one. The first part is going to be like this, and the second part is going to be like this. So it's going to be two sticks whose length sums to the length of the engine. All right, and so that way, when they constrain the lengths of themselves, they want to be the same length as the engine, but they can still be pulled off by other stresses, by stresses of gravity or velocity or other pistons attaching to this thing. So if I run that, we'll see that hopefully this line will stress a little bit. Yeah, it'll stress. And so I want that to happen on the engine as well. And if it stresses too much, then it breaks. So let's do that. So these, nope. These are going to be very similar to the piston. So we're just going to steal a lot of that functionality. We'll kill that guy. Create stick. We'll kill. We're going to kill that guy for. Well, no, we can't. This is an engine piston, and this is a init with P0, P0, and P1. Yeah, that's fine. Okay. Now this guy, the piston is going to be the driver. And right now, on an actual piston, on our piston object, it moves back and forth by 20%. And instead, we want it to move back and forth by 100%. Right? And then yeah, that should be fine. So it's going to start at angle 0. Cosine of 0 is 1. So it's going to start fully extended. And then the shaft is going to our init. Yeah, we just have an init with P0 and P1. That's fine. So our shaft is going to be ID init P0 and P1. Let's do, okay, so this is, let's give it the engine object as well. Init for engine. right? And we're going to make this an ID. And so what this is going to let us do is base the piston's length off of the engine's length instead of its own length. I think that's what we want to do. Available. I think that's how we do it. I don't want to do that. Not yet. There we go. And we can import it here. And then we can add our initializer, init for engine. If self equals super init with p0, and then we want to use the engines.p0 and engines.p1. Great. And then we can save this as a property as well. Engine. And our angle, we're actually going to start it at, let's start it at like m_2, right? That'll be fine. And then we'll return self there. Great. Okay, that's fine. So now let's update our engine object. Every engine is going to contain a piston and a shaft. Right, like that. Great. So here we can synthesize both of those. We're actually going to get rid of P2 for the moment. Yeah, that's fine, because P2 is going to be defined oops, this is P2. This is going to actually return the pistons P1. I hope that makes sense, right? P1. There we go. Move that around. Okay. Okay, good. So now we can kill P2 here. It's fine. We can create our piston. Engine piston. We create our piston from ourselves. Stick. Yep. Constrain, thank you very much. Shaft will be constrained. Our engine, we're going to render our engine, and we're going to render shaft. Let's update those so that way everything gets mixed up there. Okay. So now we have I think we're in a good spot. Right? So now we have our engine line. We have our piston line here, which is based off of this guy. And we have, now we need to make the shaft. Now the piston right here, it's reusing P1. Its P1 is actually going to be the P2 of the engine, right? Thank you. Point with X, and it's going to be engines P1.X and engines P1.Y, right? We don't want to reuse the same one because we want 3 points in total, right? It feels good. I like that. So now the other thing we need to do, let's get this compiling. Okay, yeah, that's fine. The engine shaft is going to be init with engine piston. There you go. There we go. So that means our engine is our very base ownership. Our piston, which is the next guy, is based on the engine, and the shaft is based on the piston, which is based on the engine, right? So they all kind of, they flow in one direction. Their ownership, so to speak, flows in one direction. Okay. So now we should get a warning. Yes, we do. There we go. And now this guy, piston, which is fine. Super init with P0, and the P0 of the shaft is going to be the pistons P1, and then the pistons dot engine. Do I not have a property for that? I should make a property for that. Yep. So property read only, and then engine, and then we will synthesize that. So now the shaft can access the piston's engine dot P1. There we go, and then piston equals piston, return self. Oh, a for class? Okay, yeah, we just need to import the just need to import the header file. So now we're good. Awesome. So now this guy, the piston, is going to be the guy pushing the length, right? So this is going to be, actually we can do the engine length times the cosine of the angle. Right? Yep. And now the shaft does not need an angle because the shaft's length is based on the engine's length minus the piston's length, right? And then we need to be able to create a new one here. Oh, sorry, piston.engine. Yep. And then here we can do where do I do create stick with P0? Do I not even call this anywhere? Why do I have it if I don't call it? Why am I even bothering? That used to be, I think, when we were replacing points, we used that method, but now we don't even need it. Great, that's even better. Yeah, awesome. Okay, cool. So now we should have our engine. Our engine creates a piston. Our piston, does it create the, it does not create the shaft, so we need to create the shaft. Engine shaft, and it with engine piston. Right? So now I have one of those. So we have P2, which is the, that's the engine powered point, is really the piston's P1, because the piston creates a new point, the P2 of the engine, and that's what it uses. It's based on the length. I think we're good. I think that's what we want it to do. And now when we create an engine, it should create a triangle, basically. Let's see what happens. If I do that, oh my goodness, something terrible happened. That's awesome. Okay, so let's figure it out. X is not a number. Probably because distance is 0. Percent is negative infinity. Oh my goodness. Because our difference, what's our difference? Our difference is a number and our distance isn't, so it's infinite. Is inf, does that do, maybe we want is finite. I don't know if is_inf also handles negative infinity, or if it's not finite. Yep. Here we go, dx dy. So the problem is that happens when distance is 0. So somebody's point, one of the points is getting initialized to 0, 0. You see that in the top left? So that's a problem. That is a problem. So who gets initialized to 0, 0? The engine, the piston, and the shaft gets... Let's just put some breakpoints in here and figure out who's getting a 0, 0. It is Objective-C. Okay, so our engine piston has 2 points, 2 correct legitimate points. Our shaft has a P0 of nil. So why does it have a P0 of nil if piston, oh that's why, because piston needs to be underscore piston. Okay, so let's fix that and see what we do. So this guy has real points. This guy has real points. And self has real points. Right? Great. There we go. Something worked. It at least didn't break a horrible, terrible death. There we go. Let's turn it on. Nothing happens. So the engine tick moves the angle. the angle of the engine. I don't think the engine needs an angle because our piston is the guy with the angle now, right? Yeah. So let's remove that guy. And we need to tick the piston, and we need to tick the shaft. There we go. That looks right. The engine sets its angle to pi over 2, but the engine is not going to have an angle anymore. Set angle. Engine, he doesn't have any angle there. He's gone. Piston. He has an angle. He starts at pi over 2, which is fine. And then he ticks properly, which is fine. Okay, let's see what that does. I think that will do what we want. I thought that last time. So there we go. There we go. On. Ah, that's cool. And by cool, I mean broken. Okay, so this looks like our engine's length is being set incorrectly, and we can see that at when I drag it out and then let go, it should stay at this length, but you can see it moves over to the right, right? Like that's very awkward, and that's part of our problem. Okay, so let's fix that somehow. Oh, good heavens, that is going to be a seizure. Okay, so our engine. Our engine gets P0 and P1. So this guy should always be P0 and P1. No matter what. Let's not constrain our piston and our shaft and see if we stay put. Yeah, we do. So that means somewhere our piston and our shaft's points and lengths are not initializing correctly, I believe. So our piston's length is our engine's length minus the angle. Okay, so one of the problems is that the P2 of the engine is different than our angle. So if we initialize our angle to 0, then our engine's length, this guy right here, is cosine of 1 of the engine length, which is 1, which means that the piston should be fully extended, which means that P2 will actually start at P1. So that might be part of the problem, is I was initializing the angle wrong. Now the shaft should start where the piston leaves off and pick up where the engine stops, which is fine. And its length should be the length minus, so that's fine. So now let's see what happens there. It might have just been a misinitialized angle. That looks better. Make a stick movable. That's amazing. Oh my gosh, come on. I know what the problem is. Cosine doesn't go from 0 to 1. Cosine goes from -1 to 1, right? So if we add 1 and divide by 2, now it goes from 0 to 2. We divide by 2, now it goes from 0 to 1. So now we should be in a better place, right? Goes back and forth. Yeah, that's awesome. And it wiggles back and forth. See, that's the physics we want, right? So if we pick it up, can we pick it up? Let me pick it up. I hate this stupid, there we go. All right, so he's gonna go here. Make that guy immovable and that guy immovable. We turn it on. Yeah, now it just goes back and forth and gravity affects it, which is awesome. That looks really cool. That's what we want, because now we can, yeah, now we can add different things, and we can add like a piston here and here and a stick and do like just ridiculously crazy things based on the engine. That feels better. That's a much cooler looking engine than our other one, and it's gonna play with our engine. I mean, physics engine, not a device engine. Much better. And now when it breaks, who knows what's gonna happen when it breaks? I have no idea. If we do a piston from there to there, who knows? This is just foolish now. Ridiculous. Okay, great. So now what we want to do is I would like to initialize it so the engine does not start at P1 of the engine. So that way, when we create one, we can actually see the dot in the middle instead of seeing the dot at the end of the line. New engine model. Great. That's much better. And that we can actually merge that back in because we're there we go. Okay. All right. Let's go to piston. So our angle is in pi over 2, right? Then our length divided by our engine length. That's our percent, right? So our P2 of engine yeah, so our P2 of engine dot x is equal to, sorry, my brain just kind of fried right there, minus, so we start at P0 and we add in the diff x is the engine P1 dot x minus engine P0 dot x, so diff x times percent len, right? So now we're moving it to its actual starting location based on whatever the angle is that we set here. So we can set it to whatever the hell angle we want, and it's going to update, it's going to initialize its endpoint at the correct place, which is good. That's what we want to do. P0.y plus diff y, and diff y we're going to calculate here. So that's the correct place to be. And then we also want to tell the point to null its velocity. That's what we wanted. Okay, so now it should initialize in a different place. Let's see if that works. There we go. Yep. Pink. And we can see it starts in the middle, which is awesome. If we make that immovable and that immovable, we're going to have a really bad day. It breaks, which is fine. But if we make this immovable and this immovable, then it's going to go back and forth, just like we want. It's awesome. And now we can initialize it also really, really easily to whatever we want it to be, which is good. Cool. Cool, cool, cool. Initialize engine to something else. Oh, come on. Knit engine. Okay, now that code's up, so you can pull it down if you want to. I'm not looking at YouTube. Yeah, so the YouTube chat's empty right now, which is fine. Just wanted to make sure I'm not missing anything. Right? Yeah, great. Okay. So what's next? Now we have engines, we have sticks, we have pistons. We should do animations when things break. That's what I think we should do. Right? That would be awesome. So if we create something right here and we make a piston right here, then that's probably going to, is that going to break something? I just want to get an easy test case. Ooh, that almost does. Yeah, it's almost a really bad day. Okay, so let's try something else. Let's try, we're going to doubly reinforce this thing. And then if I make a piston right here, now, I messed up my dragging. Now is that going to break something? No, it won't. Okay. Maybe I just need a better square. Or maybe I just need to make yeah, let's just make our coal sticks. Let's just break it on 0.5 instead, right? I think that's fine. There we go. So now we're just going to make things really really fragile. So now this should break. Come on, I can't draw for heavens. We should fix that bug one day, where the gesture just has a really bad time. Okay, there we go. So now when we turn it on, yep, yeah, we saw it break a lot sooner, right? That piston breaks. So let's animate that piston breaking. So when it breaks, we actually have like pieces that fly across the screen. I think that would be fun. Let's do that. Let's go to here, coal, right? So sticks remove. So we're going to CG point P0 equal s dot P0 dot add CG point and P1. So we're actually going to call this P4 and we're going to put 2 points in the middle of it. So we're going to calculate a P1 and we're going to calculate a P2. Right? So P1 is going to be point make P0.x plus, we're going to make it like 30% times xdiff. And we're going to do the same thing here, P0.y plus 0.3 times ydiff. So we need to calculate our xdiff is P3.x minus P0.x. And our ydiff is the y's of that. So we're just chopping the segment, all right, the segment of whichever stick broke. We're just going to chop it into 3 pieces. and then we're going to make 3 sticks. And when we remove this guy, we're going to put in the other 3 sticks. So that way they just take the place visually, and then they can fall down off of the machine, right? So that's that guy, and then this guy is the same thing, except we're going to be 0.6. That looks right. So now we do S1 equals stick with P0, point with CG point, P0, and MM point, P1. Awesome. So now we have our 3 sticks. That goes from 0 to 1, from 1 to 2, and from 2 to 3. And then we can just do sticks, add objects from array, S1, S2, and S3. Right? So now we should, I hope that works. So now we should be able to make our box and break the piston, and then when this piston breaks, we should see, yeah, they show up, but they don't update because our points, we need to add our points to our points array. S1.P0, S1.P1, S2.P0, S2.P1, S3.P0, S3.P1. Right? And then we're also going to do, we're going to take all these new points, oops, and then we're going to new points, make objects perform selector, bump. Yeah, we should do bump. That's fine. Right, and that's going to move them a little bit so they don't just fall all straight down, but they kind of wobble off. Let's try that. There we go. Man, I think that the pan gesture requires movement of at least X pixels sometimes, or at least X touches sometimes. I do not understand why it begins the gesture like 30 pixels away from where I start clicking. But sometimes it does. So I'm going to turn that on, so now we've turned it on, pop. Wow, 2 things broke. Is that what happened? 2 things broke at the same time? Pop. That's awesome. Pop. That's pretty great. I like it. Things break. There we go. Now that code is up. All right, what should we do next? You guys have any ideas? Maybe. So I think wheels might be interesting, or gears of sorts, right? Like some sort of spinning circular thing. Maybe that would be fun. So the thing right now is we don't have any friction defined. I mean, not really any friction. So if we create a circle and it falls down on the floor and we have it spinning, it's not actually going to go anywhere. But maybe that would be an interesting problem to solve. I think that could be fun. We could Let's try it. Let's just see how far we get. Yeah. My thought is, here's my thought. Oops, let's turn this off so I can draw something. So my thought is we make a circle like that, except it would actually be a circle. There would be the center point that would define the circle. There would be some radius that would define how large the circle is. And then there would be, I think, 2 points that you could also attach things to on the circle, kind of in the middle. And that would let us like take our engine, and then we could attach this engine onto this and end up making something that looks a little bit like a train wheel, right? Where this guy goes back and forth, which pushes this stick, and the stick ends up pushing the circle as it goes back and forth. Does that make sense? So I think that would be an interesting goal to create. Another thought actually that we could do, let's do this first. Let's do, before we do wheels or circles, let's do balloons that have a different gravity, right? That fight gravity. So they would have a buoyancy that fights gravity, and then you could attach that balloon to something. Let's do that, because that'll be a lot easier than wheels, and that'll get us started with circular looking objects. Balloon, and the balloon is going to extend a point, I think. That feels right to me. So now let's do point objects, and we can do, oops, that's the wrong button, and we can do stick objects. So point objects go in here, stick objects go in here, right? And then everything else goes up here. Now we're organized a little bit. Okay, so our point can be bumped, it can be created, we can get a distance, we can set, we can render, we can null velocity. So I think, let's go to update points and see what happens. I think update points, yeah, is just here. So what I think we also want to do, should we let's have, if py is gravity, my thought is how do we give gravity to the point and ask the point to update itself with a given gravity? I think that's a fine way to do it, right? So if we do update with gravity, I think that's fine. And so then that means that this stuff here, if p is not immovable, even if p is immovable, we can do update with gravity, like that. And then this stuff can go inside of that method here. We can do if not immovable, and that way the point can decide how it wants to live its life. Oh yeah, we need to do and friction. Oops, and friction, thank you. Let's autocomplete that. So now the point can decide by itself how it wants to update, or if it wants to update, right? Which is great, because now we can say for a balloon, we're just going to we're just going to negate gravity, right? And that's super easy. And now when we, does this render itself? How do we render points? I think rendering points we also do. We might not render points at all, actually, because sticks render their own points. So balloon stick is just an object. Let's make stick extend a renderable, maybe. And then the balloon can extend renderable instead of point, and it can contain a point just like anything else. I might be going a little overboard on the organization, but I think this is a good way to do it, right? And then that way a balloon also extends renderable. So these are not really, these are renderable objects, right? And so then a balloon would be init with point. I feel like that's a good way to do it. And then, oops, that's not even close to the right place to put that. Self, and then here we go here. Oops. Synthesize p is equal to point, and we're going to create a property which is read only, which is going to be point. There we go. And this is going to be p update with gravity. This might still be a terrible way to do it, because sticks or things like sticks don't have a way to update with gravity. Only points have a way to update with gravity. Erg. Maybe we had it right the first time. Yeah, I think we had it right the first time. We're going to have it right the first time. We're just going to, yeah, that's fine. So this is going to revert, because otherwise we're adding a bunch of classes, we're confusing a bunch of things, we're doing a bunch of stuff we just don't care about. So that means balloon is going to extend point. Yep. And we're going to extend point. Yeah, that's fine. I like that. It's easier. It's fewer classes. It's fewer stuff. It's fewer everything. Yeah, I like that. And then we're actually going to give this its own render method, which is fine. Do points have a render method? Yep, they do. So we're going to render its point, and we're also going to render an arc here, We want a radius. The radius is going to be 25. This is going to be the balloon path. Self. Yep. And then we're going to do, balloons are going to be green. Set stroke. And then stroke. Right? I like that. So that means here, instead of just having points and sticks, this is how we're going to solve the problem. We're also going to have balloons. And so then in our render method down here, we're going to render everything, and we're also going to render balloons. And then balloon. Balloon is one of those words that when you look at it long enough, it doesn't look like a word anymore. It looks like not a word. It looks like ridiculousness. Okay, good. Now I think we're okay. Awesome. Awesome. So that means balloons should act just like points, except they float, which is what we want. So now we need to be able to make a way to create things. So let's do a create balloon gesture. Balloon gesture like this. It's going to be a UI tap gesture recognizer, right? Yep, it is going to be that. This create balloon gesture. Now we're going to make it a pan gesture because we have another tap gesture that selects points. No, we're gonna make it a tap. We'll fix the UI. We'll fix kind of the interface later, but this is gonna be fine. Create balloon. Awesome. Create balloon gesture, and it's a UI tap gesture. And then if it is recognized, then we're going to create our balloon at that point. Look, init. Do I not have an initializer? I think I want one of these, right? I'm going to do a balloon with a point. Yep. Init, and our point is going to have to give us our initialize method. Oh no, we don't even need one. Yeah, we just need to do that. Hit. P.y, P.x, no velocity, return our balloon. Great. So now when we create it, we have our balloon with point, curloc, and we're done. Add object, balloon, and we do points, add object, and since it's a point, we add it there as well. Awesome. So now I think we need to just initialize this array because it's currently not initialized. There we go. And now I believe we can make balloons, except we need to make the segmented control. We need to have another option there, right? It's going to, we're not going to put it as the first one, we're going to put it as the right before move point. Great. We want to move it left a little bit because now we got more stuffs in there. And this is going to be create balloon gesture is enabled if it's a 3, otherwise grab if it's a 4. Okay, I think that's what we want. Let's try it. Let's see if we can create balloons. Are we not rendering them? Do we ever call that? Yeah, we call it. Maybe it's not getting created when I tap. Nope. Nope, it's never being called. Maybe it's because of the other tap gesture. Isn't there like a can recognize simultaneously method or property? Oh, you know what it is? No, we add it here. Enabled no. I feel like it's because, so that gesture still works. What if I add it after? Is this guy stealing the thing? It's enabled when the segment is 3, 0, 1, 2, 3. Something happened. Super. Look at that. It's a balloon. Boy, that bounces a lot. My goodness. That's pretty great though. Oops. So now if we connect all of these balloons together and add a little thing that they can carry. Oops. So I think that's 1, 2, 3, 4, 5. I think you need one balloon per point. 1, 2, 3, 4, 5. So now I think it would hover, right? Let's see. Yeah, now it's slowly lifting off. That's awesome. That's so much fun. Balloons. Those balloons are ugly. We're gonna update the graphics one day. Not today. Balloons. I cannot for the life of me type a exclamation point. That's funny. Balloons. Hey, there, I got the exclamation point. That's great. Cool. So now balloons are up there, which is pretty great. So somebody asks, freeze back. How much time did you spend on this project? This is day 4 of kind of 1 to 2 hour streams. So it's at like 6 hours, 6 or 7 hours, I think we've put into this so far. And it's all on stream, so you can go back and look at the other ones as well, if you would like. Hi, Victor. So that's pretty great. Now we have balloons, and it's hovering. Look at that. It's off the ground at the bottom. It's not touching the top. It is exactly hovering. That's so cool. That's a lot of fun. What should we do next? Maybe we should do the wheels next. Right? Wouldn't that be good? I think that would be good. We're doing all kinds of things today, making all kinds of stuffs. Let's do wheels. Let's try to do wheels or gears. I don't know what we're going to call them. Let's call them wheels. So renderable objects. This is really stick objects. Thank you very much. So a stick object is going to be a wheel object. I think is going to be defined by, I think it's going to be defined by 3 points. So it's going to be defined by the click point. We're going to create it just like a balloon. So you click to create. We're going to define it with an angle. And the angle is going to be the angle of rotation, which is going to give us our 2 other points. I would like those to be, so this is going to be a similar problem to the engine, right? So when we create an engine, this 3rd point here is actually created of other things, right? That are defined by the physics engine. And I would like the 2 points of the wheel to be these endpoints here, right? I hope this makes sense. So our circle kind of goes around like this, right? And this guy right here is our axis that connects these 2 points, and the angle defines the angle around the wheel, the wheel spin, right? But it's not going to be a powered wheel, so we actually don't need to store the angle, right? So let's do this. We're not going to store the angle. Oh, that's funny. Our clear method, we need to update the clear method. Let's do that real quick. So it deletes. So now when we hit play, they don't happen because they're out of the points array, but they're still in the balloons array. Balloons, remove all objects. There we go. Great. Let's make sure we can clear balloons. Balloons, yay, balloons. Stuff, great. Yeah, they clear. Okay. Clear balloons. Okay, cool. So all the code's up. There's the code. You can see it on screen. That's the repo. It's just on GitHub, so you can all pull it down if you want to, and play with it. So now let's go back to thinking about it. So if we think about it, there's 3 points in our wheel. There's the center point, which defines the wheel, and then there's 2 other points. And it's not a powered wheel. So if our wheel goes around, that's our border, right? That's the border of the wheel. So that means all 3 of these points might be pushed by other things. So this piston might be pushing that guy, this piston might be pushing this guy, and this piston over here might be pushing this guy. And I think when we constrain the object, we want to constrain so that these are all collinear, right? They're all collinear, and the length between here and here, and the length between here and here, and the length between here and here is always the same, is always unchanging. So that we can model with 3 sticks, just like we do with the engine. where the engine is modeled by its primary stick is a static length and then 2 substicks of changing length. We can do the exact same thing here, except it's 1 stick of static length and 2 substicks of also static length. So that'll help constrain. That might do everything we need, actually, to constrain all of our stuff. Yeah, let's try it that way and just kind of see what it ends up looking like. So it's going to be a stick object. We're going to call it mm wheel. It's going to extend a stick, which is great. Wheel. I don't actually know if the wheel is going to need any subparts, but let's just pretend that it does. So we're going to get this guy, and then wheel, and we're going to have a wheel with P0, P1, which is fine. Our stick gets, this is the initializer we want. If self is equal to super, and it with P0, P0, and P1. There we go. And now we're going to do return, and then wheel, loc, init with P0. P1, just our little helper class method there. We're going to have 2 substicks, substick 1. We're just going to call it stick 1 and stick 2. What do they call it? Spoke. We'll call them spokes, right? Spoke 1 and spoke 2 because it's a wheel. So spoke 1. We're going to have a CG float of our diff x is equal to P0 as, oops, sorry. Does this not have our, it does, right? P0. Why isn't it auto-completing? As CG point. What are you angry about? Oh, because of an underscore. We can do self.p0 as CG point, right? Yeah. But we want 1 minus self.p0.as_CG_point.x. That's our diff x. This is our diff y. This is our center point, which we're going to need a property for. Oh, actually, this is going to be a wheel with P0 and radius. That's how we want to define it, right? Yeah. The answer is yes. The answer is always yes. So that means wheel with center. Center. So we're going to have property, read only, center. P0 and P1. Right? I like it. And then here, we're going to synthesize P0. Well, P0, we already extend stick, so we already have a P0 and a P1. We just need to add the center property. So we synthesize center, which is great. So we're going to initialize it with P0. This is going to be wheel with center. is equal to, and we're just going to calculate these, right? Does this have a helper method? I don't remember. Yeah, center. That's what we want. And P1. So right now they're all the exact same, which is fine. P0 dot x minus equals radius. P1 plus equals radius. Now they're on either side, which is great. Now we need to null their velocity, which is great. There we go. Yeah, we're gonna do that's fine. Init with center. And P0. Yep, center, center, P0, P1. There we go. So this is actually going from, yeah, P0 to P1. That's fine. So what are you angry about? Oh, you're angry because I don't have an opening bracket. That's fine. Okay, good. Equals center. So now after this happens, our superclass, which is a stick, will have saved P0 and P1 and have created our outer stick. So now we need to create our two spoke objects. Stick with P0. So the first stick is going to go from P0 to center. And our second stick is going to go from center to P1. Right? Great. And now, just like our engine, we have our tick, constrain, and render methods. And our replace point method that I was staring at, confused. And now we're going to make sure that we update and constrain all of our things. Here we go. So now we render all of the things, which is great. And then we're also going to render the actual wheel around it. Center. There we go. With our radius, which we should have saved up here. Our radius is actually just going to be the radius is our distance from our center, distance from point. There we go. I know that we have it here and we're just recalculating it here, but that's fine. So there's our radius. We create it. Wheels are going to be, what color should wheels be? Should we make wheels brown or something? Brown's a terrible color. I think we should make them, we'll make them blue, just like sticks. That's fine. There we go, replace point. Okay, now I think we have a wheel. I think that's it. Right? That's it. So create balloon gesture. Instead of creating balloon, let's just create a wheel real quickly. And just make sure that things work, and then we'll add in the UI. And wheel. balloon. Wheel with center. Current loc. We're going to make the radius 40. It's going to be giant. That's great. Points, add object. The wheel.center. We're going to add wheel.p0 and wheel.p1. Look, there we go. And then this goes here, which we don't need to name it, because why are we naming things that we don't need to name? There we go. And then since it's a stick, we can add our object. It extends stick anyway, so we can just add it to our sticks array. That sticks array we probably need to rename eventually, but I think that's going to create a wheel. Yeah, did something. Let's make that movable. Let's make a piston right there and see what happens. Yeah. It's constrained pretty nicely, right? That's pretty awesome. Let's make yeah, it just broke. That's awesome. Cool. Let's actually make the wheel have 4 points, one on each side. Wouldn't that be good? I feel like that would be good. It's going to be good. So our wheel is going to have more spokes. So we're going to have 4 spokes, the 1 and the 2, and then we're going to have a 3 and a 4 with another crossbar. A 3 and a 4. We're going to do init with center and radius. So now we're calculating our points inside of here. Do that. Okay, there we go. So let's do the initial crossbar. So we're going to do init with center and radius, which is center and radius. Great. So that's fine. So now that we've created here, we've created our guy, so we can add our spokes. Now let's create the other spokes. So we have in a point, we're going to do P2. Man, I cannot type. Okay, here we go. P2. P2.y, right? Instead of .x. And then P2 null velocity. There we go. So that's 1 point. And then P3 is our other guy. Right? And so then our spokes 3 and 4 are going to go from our center to P2 and our center to P3. And we actually need this is spoke 3 and 4. We actually need a spoke 5. This is going to be the crossbar, is actually what we're going to call that. The crossbar is going to make sure that from P2 to P3 stays put. Right? Yep. Yep. That's fine. I like that. So now when we create it, so now we should do, it's actually going to flop around a little bit, and that's fine. We'll fix that in a minute. But I just want to validate that it's building what I think it's building. Yeah, 3, and this is going to be render. I replaced the wrong thing, which didn't make any sense. Let's constrain. Great. Great. Spoke 3 and 4 here, and the crossbar. That's fine. So now the wheel is actually going to flop around. It's going to have a couple different things. So let's make it. Ooh, yeah, I didn't do that right either. This should be a plus radius. Okay, let's try again. There we go. So here we go. So now it's correct, which is fine. If we do a stick here, make it immovable. This top spoke, nothing's actually, well, are things holding it up? Nothing's holding it, nothing's holding it to be a right angle, but it is being held up. Yeah, you can see they're kind of flopping a little bit. And so if I add a piston to like this guy, it's not being held at a right angle of anything. So let's create, let's make this crossbar 1. Make that crossbar 1. We're going to add 2 more crossbars between points like 1 and 3 and 2 and 4, or whatever the correct numbers are. And that's going to force, that is going to force the 90 degree, which is what we want. So between P0, and we'll just pick one, P2, and P1 and P3, right? That feels right to me. Tick. 3. Constrain and constrain. Awesome. We're going to do a render here. Awesome. And we're going to do the replace point here. 2 and 3. So now we should get cross beams between those 2 points, which is going to help help force it to stay at 90 degrees. Right? So if I create a stick, it's just going to hang from there, and we're going to piston from here. Did that? Oh, it. Am I not adding all? I'm probably not adding all of the points because I'm adding P3 and P4. So we have center, and we also have P3 and P4. That's the other thing I wasn't doing, is I wasn't adding those points into our points array. There we go. Wheel P3 and P4. Yeah, I wasn't assigning them to the property. Synthesize P3 and P4. And did I synthesize P3 and P4? I named them wrong. This is P2 and P3. 2 and P3. And then self.p2, p3. There we go. That's what we like about things. There we go. That works. That's what we want. And then I need to update here. Oops. To P2 and P3. Okay, great. So now we have everything the way we want it to be. So if we add our balloon, if we make a stick, it's going to hang from there. And then we make our piston to make it move around a little bit. The wheel tries to stay, see, it's not perfect, but it tries to stay 90 degree. It's a little bit floppier than I thought it would be, in all honesty. It might be too floppy. Do you think it's too floppy? Maybe it's too floppy. What if we do our crossbars is less than 5. What if we really constrain the crossbars? There we go, and then a piston, go there. Movable, movable. Is that less floppy? Well, that's not what I expected. Might be because it's trying to pull it shorter than the stick allows it. So if we come down here, now it turns the wheel. So that's kind of cool, and it might still be a little bit too floppy, but it might be okay. That might be like a little bit of the derpiness that we want in this kind of a thing, because we're not going for perfect physics. We're just going for something that's fun to dink around with. And even though the points are kind of floppy on the edge of the wheel, they are at least yeah, I think that's okay. That's probably okay, right? I like that. Yeah. Yes, the answer is yes. Okay, so the other thing is when we turn this point movable off, see it's on the floor, and it actually goes underneath the floor a little bit. Let's fix that so that way the wheel always stays the correct length away from where it's supposed to be. And to do that is in constrained points, I believe, right? Let's look here. So constrained points. This guy makes sure points stay inside of our box, right? That method makes sure all of the points that we ever create stay inside of and bounce off of these points. But what we really want is for a point. If a point is the center of a wheel, we want it to stay not just inside of this thing, but we want it to stay a radius distance away from the edge of this thing. So if we do inside, let's do sticks. Stick is object. Objects at index, please. If S is kind of class, and then wheel. So if it's a wheel, S, right? Oops, S. So now we want to make sure center of wheel is inside the box. right? So now this guy, let's make a block real quick. Process point. Oops, this is actually an endpoint. Did I get it? Look at that. Block syntax the first time. Guy's a pro. There we go. Process point. Awesome. I like it. So we want to do the same thing here. We want to process the point for the wheel's center. Now this actually gets me thinking. This is it's a little bit ugly to do it like this. We could, I don't want to process it twice, right? That's the thing. I don't want to process it twice. And right now I'm going to process it twice. I'm going to process the wheel, and then I'm going to process the point, which is inside of the points array. So how do we not do that? This is going to be a really terrible thing to do. But we're not going for performance yet because our performance has been just fine. And so we'll optimize it when we need to optimize it. But so far we haven't needed to. So there we go. And then if not processed contains object. So if it doesn't contain it, then we process it, right? That's fine. So now it's only going to be processed once. Great. And now this guy, we want to process with a distance float. And these points here only care about that, and this cares about the radius. Do I not? Is that not a property of the wheel? It should be. Radius, awesome. And then here we can synthesize it. Radius, awesome. We don't need that anymore. And now we're good. Okay, cool. So now this guy tries to process it within a radius, and this guy processes it within this. So p.x minus distance is less than distance minus distance greater than distance. So now our wheel should hover above the floor. Let's make sure that that's true. Bonk. Yep. Yeah, now it actually acts like a wheel, which is nice. That's cool. And the friction of it rolling doesn't actually do anything yet, but that's okay. So now let's update our UI so we can make balloons and wheels, which I think would be a fine thing to do. Wheel v1 is what we'll call it. So we have that stuff. Awesome. And now let's, what were we going to do? Yeah, we're going to update our UI. Yeah. Yep. That's what we're going to do. Make balloon. I want to make wheel. I still don't know if we should call it a wheel or if we should call it a gear or something like that. But there's a better word. But it feels like an okay word for now. So the UI segmented control, and we also need a new gesture. This is going to be the create wheel gesture. Great. Here we go. It's going to be create wheel gesture. Okay. So now our segmented control here, we can do the create wheel and enable that. If it's a 4. Oops, sorry, mode. Yeah. Yep. So then we actually have our, the other thing we're going to do is we're going to move the tap gesture. Oops. I beg your pardon. We're going to call it a select point gesture. And that guy is this guy. And then he is going to be enabled if this guy is not enabled and if the create balloon gesture is not enabled. Right? That makes sense. Oops. That just indents really terrible. Okay. So then we go down to create balloon. This guy is now called create wheel gesture, which is great. And then this guy gets to go back to being the create balloon gesture. So now I think we have both. Let's see if we can create wheels and balloons. Make a wheel. Bonk. It does not bounce, which is interesting. It probably doesn't bounce because it's so... Is it because it's so heavy? Because it has like 4 other points in it? I don't know. If we do that, so that way it lands on the radius of the center. Bonk. Oops, that made it worse. There we go. There we go. How do I get that thing to stop swinging? You stop swinging now? Yeah, now you've stopped swinging. But now when I drop this, it's going to land on This is stupid. There we go. Let's make a wheel. Make a stick. Make a stick. And now this guy can be movable, so when it drops, it still doesn't bounce. I don't know why it doesn't bounce, but that's okay. It doesn't need to bounce. Balloon. Great. Okay, so now all that code is up. I'm very curious why it doesn't bounce. Can we think why it doesn't bounce? It's not doing it twice, is it? so we're getting that going. So that means it's not processing it twice, even though my comment made it look otherwise. So that's good. Oh, you know why? I bet I know why. I think it's because so when we drop the wheel hits its constraint, so it bounces. The center tries to bounce, but because all the points on the sides, those 4 other points have not wanted to bounce, it they're continuing to move down. So 4 points are still moving down. 1 point is trying to bounce up, and the 4 points override the 1 point. So I think if we actually did process point, I think what we need to do is we need to change this. So constrain points, we're actually going to do a constrain wheels, and this will handle bouncing wheels, because when something bounces, when the wheel bounces, I need to update the velocity of not only the center point, but I need to treat all 4 points as if they had all bounced off of the edge of the screen at the same time. That's what I need to do. So let's do that real quickly. We're going to take this block away, because I was very proud of having remembered my block syntax. There we go. And then that's a 0. Let's put this back to 0. Let's put this back to 0. Let's put this to 0 and this to 0. All right, so now this guy's back to normal. Processed points. Go. This mutable set. Okay. That's now every time before we do every tick, basically, we want to reprocess everything. Oops. So then, yeah, update. We want constrain points. That's where we care about processing, right? So we'll come down here and constrain everything. So if process points doesn't contain it, we're going to add it, which is fine. And now here, we're also going to go through this is where we're going to go through the sticks and look for wheels. Object of index, if stick is kind of class, and then wheel, then we're going to process that. Okay. That doesn't make any sense. There we go. Now we're going to constrain the wheel. This will be good because we can actually make wheels bounce a little bit differently than everything else if we really wanted to. But that's fine. So now we go here. So now we're just going to blindly add the wheel because we know we get processed first as a wheel no matter what. This is going to be, oops, wheel at center. If we are not immovable, then we want to do stuffs. This is the velocity of the wheel, which is good. This is the wheel.radius. There we go. And this is going to be wheel.radius. Wheel.radius minus wheel.radius. There we go. Go. There we go. And now the tricky thing is that we want to make sure, see how we're forcing the Y and we're forcing the old Y to be in new kind of valid locations to help out with the bouncing, which is great. But we also want to update other than 4 points. And when we want to offset all 4 of those points the same amount that we just offset this guy, right? And by the same velocity. So we can do wheel dot, we have P0, we have P1, 2, 3, 4, right? So this is yeah, so if this wheel X is greater than where it should be, by let's just make up a number, 10 pixels, right? Then that means all 4 of the other points on the wheel are also too far by 10 pixels. And so we need to pull this guy back by 10, and we also need to pull everything else back by 10, right? Make sense? So that's what we're going to do. Move X equals 0. Move Y equals 0. Right? That's how much we just moved the X. That minus, oops. That, we actually want radius minus center. Because radius minus center, because the center is like 5 and the radius is 4, then we want to move to the right. I mean, if radius is 10, yep. Okay, great. And then here we have move Y, center dot Y, and we're going to take I did that wrong. That should be width. Here we go. I did that wrong. I don't know what happened there. Move Y, center Y, bound size height, center dot Y. And so now we can do move X. Oops. Move Y, right? So now they're all adjusted by the correct amount. And now I need to bounce their velocity. So the old X is going to be how do I bounce their velocity? It's center X plus the Vx times bounce. Oh, yeah. So he's just putting the, yeah. Okay, yep. Yeah. Maybe we should make these Vx's a property of the point. I feel like that would be helpful. There we go, velocity for friction. And then we can take these guys, put them here. There we go. Now here we can do wheel.center, velocity for friction, right? Now that becomes v.x, v.y, v.y. There we go. So now we can do for and then point p in an array of wheel.p0, wheel.p1, wheel.p2, wheel.p3. There we go. Awesome. And then we can also update their, if we had to move it by X, then we know we bounced off the X wall, right? And if we moved by Y, then we know we bounced off the Y wall. Great. So we can do CG point V equals the P velocity for friction. Okay. And now we can get our old Y here. This feels good. I like the way this is working out. I think this is a fine way to do it. All right. And we can also do here, do X. Let's try that. I think that's okay. This is going to mean that, yeah, this will constrain, yeah. Okay, this is fine. Let's do this. Let's see what happens. Let's just see what happens. I think this will do what we want, because I think when center bounces, it's also going to cause all of these guys to bounce. right? And I actually don't need to loop through them unless something happened. Let's prematurely optimize that a little bit. I think that's what we want. I'm pretty sure. Are you gonna bounce now? No, you're not. And you're not constrained at all. And that's because I don't call constrain wheels anywhere. Let's call constrain wheels here. Okay, I think I don't know what's happening there. That's a disaster waiting to happen. Velocity, so I have a velocity, it's downward. My center x is greater than the width minus wheel dot radius. Thank you very much. There we go. So now all of those things are being pulled downward. So the very first time it hits the bottom, move y by 694? That doesn't feel right at all. There we go. Okay, so now the move y moves up 20 pixels because it's moving about, it's moving a velocity of 20, so that's fine. So that means I want to move everything else 20 pixels also, I believe. I think that's okay. Because all of their stuff is way down there. I think I moved in the wrong way. There we go. Now we have bouncing wheels. Oh, that didn't work. Can I bounce it off the top? Nope, I cannot bounce it off the top. Can I bounce it off the left? Nope. Well, maybe. Yeah, so the right and the bottom work okay. The left does not work okay. So if the center x is less than the radius, then movement needs to be probably center minus radius, maybe? Is that my problem? There we go. Great. Great. That's awesome. Now we have bouncing wheels. Bouncing wheels. So the interesting thing is that when it hits the wall, it stops rotating, doesn't it? Yeah, it does. And I don't think we want it to do that. I think the problem is our old X. So how do we want that to happen? So if it hits the edge, right? Right now we're making all of them maybe that's okay. Maybe we are doing the right thing. We might need to flip the Y velocities as well for all of the other points. Because if I go here, if I want it to spin the opposite direction when it hits a wall, instead of continuing, then that's the... I don't know, but I think that's fine for now. That's fine for now. What did we do in this one? We did, oh yeah, we process wheels. Oh, you know what we're also going to do? Allow wheel bounce. Actually, never mind. It doesn't matter. Because when we constrain points by doing this, by fixing all of these as well, they will never need to be processed here. So we can do process points, add objects from array. We can add all those too. Points and don't duplicate work. Great. Cool. I think we actually got a lot done. Let's look at what we got done. We got wheels done, which is great. And wheels can do stuff. They act kind of like actually that's the wrong way. Let's make a wheel. Make a wheel here, and then we can turn it, hopefully, with that piston. Can we do that? No, it breaks. But we can do it like that. That's so silly. Cool, so we did wheels. We did the braking animation that we saw moments ago, where everything breaks if it's put under too much stress, which is pretty great. I like that a lot. We should do, and maybe next time we'll do, if a wheel breaks, or if, I don't know if we have a thing to make balloons break. I don't know if that even makes sense. Attach this to the things. We have balloons, which is a lot of fun. So balloons are great. We did balloons today, we did wheels today, we did the braking animation today. So we did a lot. So tomorrow we'll either do braking wheels. I don't know what a braking balloon would look like if we can pop a balloon. Maybe if it changes velocity too fast, then it pops. I don't know if that's a thing. If we that would be fun at all. I just want to do fun things. I don't care if we do other things. So yeah, we can do a couple other things tomorrow, but I think that's a good point today. So anyway, subscribe if you haven't, or follow on Twitch or Live Coding or on Twitter or whatever you want to do. You can also get the code. Let me show you where the code is. It's in the description. Remote. So there's the GitHub on screen or in the description. So you can click in and clone and pull it down and play with it yourself. But it's a fun little thing. We have sticks. We have pistons. We have engines, which have a point here, and then here's our piston, and maybe a balloon, and a wheel, oops, that's just silly. I think we can start building really silly contraptions. That's a lot of fun. I'm just like, I'm getting lost in the ridiculousness of what this thing is. But anyway, really cool, guys. Check it out. Thanks for hanging out. I think we're gonna call it there. And hi, Anthony. Bonjour. Anyway, check it out. Subscribe. Play with the code. We're going to do it again tomorrow. Wow, we streamed a long time, almost 2.5 hours. Sorry for the noise in the background too. That's people fixing my house, if you didn't know. But the goal of the stream is to finish this game, whatever it is that we're building, in 2 weeks. Have something of high enough quality that we can submit it to the App Store. So if you have ideas, give me your ideas. If you want to write code, send in pull requests or whatever, and we can get this going. I'm going to do 100% of the development on stream, so I'm going to try to do it again tomorrow. So follow or subscribe on Twitter, and you can show up then as well. Thanks, guys, and we'll talk to you later. See you, man. Bye.